William Gray Walter was an American-born British neurophysiologist and robotician. Overview. Walter was born in Kansas City, Missouri, in 1910. His ancestry was German, British on his father's side, and American, British on his mother's side. He was brought to England in 1915, and educated at Westminster School and afterwards in King's College, Cambridge, in 1931. He failed to obtain a research fellowship in Cambridge and so turned to doing basic and applied neurophysiological research in hospitals, in London, from 1935 to 1939 and then at the Burden Neurological Institute in Bristol, from 1939 to 1970. He also carried out research work in the United States, in the Soviet Union and in various other places in Europe. He married twice, and had 2 sons from his first marriage and 1 from the second. According to his eldest son, Nicholas Walter, he was politically on the left, a communist fellow traveler before the Second World War and an anarchist sympathizer after it. Throughout his life he was a pioneer in the field of cybernetics. In 1970 he suffered a brain injury in a motor scooter accident. He died 7 years later on May 6, 1977 without fully recovering. Brain waves. As a young man, Walter was greatly influenced by the work of the famous Russian physiologist Ivan Pavlov. He visited the lab of Hans Berger, who invented the electroencephalograph, or EEG machine, for measuring electrical activity in the brain. Walter produced his own versions of Berger's machine with improved capabilities, which allowed it to detect a variety of brain wave types ranging from the high-speed alpha waves to the slow delta waves observed during sleep. In the 1930s, Walter made a number of discoveries using his EEG machines at Burden Neurological Institute in Bristol. He was the first to determine by triangulation the surface location of the strongest alpha waves within the occipital lobe. Walter demonstrated the use of delta waves to locate brain tumors or lesions responsible for epilepsy. He developed the first brain topography machine based on EEG, using an array of spiral scan CRTs connected to high-gain amplifiers. During the Second World War he worked on scanning radar technology and guided missiles, which may have influenced his subsequent alpha wave scanning hypothesis of brain activity. In the 1960s Walter also went on to discover the contingent negative variation effect, whereby a negative spike of electrical activity appears in the brain half a second prior to a person being consciously aware of movements that he is about to make. Intriguingly, this effect brings into question the very notion of consciousness or free will, and should be considered as part of a person's overall reaction time to events. Walter's experiments with stroboscopic light, described in The Living Brain, inspired the development of a dream machine by the artist Brian Gizine and technician Ian Somerville. Robots. Gray Walter's most famous work was his construction of some of the first electronic autonomous robots. He wanted to prove that rich connections between a small number of brain cells could give rise to very complex behaviors, essentially that the secret of how the brain worked lay in how it was wired up. His first robots, which he used to call Machina Speculatrix and named Elmer and Elsie, were constructed between 1948 and 1949 and were often described as tortoises due to their shape and slow rate of movement, and because they taught us about the secrets of organization and life. The three-wheel tortoise robots were capable of phototaxis, by which they could find their way to a recharging station when they ran low on battery power. In one experiment he placed a light on the nose of a tortoise and watched as the robot observed itself in a mirror. It began flickering, he wrote, twittering, and jigging like a clumsy narcissus. Walter argued that if it were seen in an animal it might be accepted as evidence of some degree of self-awareness. One of the tortoises was modified, and had added to its simple single-celled brain, then 2 conditional reflex circuits in which they could be taught simple behaviors similar to Ivan Pavlov's dogs. This tortoise was called Cora. One of these included being hit meant food, whilst whistling means food, and when conditioned such a whistle by itself means being hit. When he added another circuit tune to a whistle of another pitch, this could become whistle means being hit, whistle means food. This would make the animal become afraid whenever food was presented. Walter remedied this behavior by severing the two additional circuits, and the tortoise reverted to being a machina speculatrix. The conditioned reflex behavior was later placed into a static desktop model, also known as Cora. Later versions of Machina Speculatrix were exhibited at the Festival of Britain in 1951. Walter stressed the importance of using purely analog electronics to simulate brain processes at a time when his contemporaries, such as Alan Turing and John von Neumann, were all turning towards a view of mental processes in terms of digital computation. His work inspired subsequent generations of robotics researchers, including Rodney Brooks, Hans Moravec, and Mark Tilden. Modern incarnations of Walter's turtles may be found in the form of beam robotics. An original tortoise is on display in London, UK, in the Science Museum's Making the Modern World Gallery. Recently, one was also replicated by Dr. Owen Holland, of the University of the West of England in 1995 using some of the original parts. An original tortoise as seen at the Festival of Britain is in the collection of the Smithsonian Institution. Walter's papers, including his letters, photographs and press cuttings, form part of the Burdand Archive held at the Science Museum Library and Archives in Wroughton Science Museum at Wroughton. Books and articles. An Electromechanical Animal, Dialectica Volume 4, 42-49. An Imitation of Life, Scientific American 182, 42-45. A Machine That Learns, Scientific American 185, 60-63. The Living Brain, New York. The Living Brain, Duckworth, London, 1953. The Living Brain, 1953, Penguin, London, 1961. Contingent Negative Variation. An electrical sign of sensory-motor association and expectancy in the human brain, Nature 203, 380-384. Gray Walter, the pioneer of real artificial life, Holland, Owen E. *, Proceedings of the 5th International Workshop on Artificial Life, Christopher Langton, editor, MIT Press, Cambridge, 1997, ISBN 0-262-62111-8. p34-44. Walter's World, New Scientist, the 25th of July 98. The Tortoise and the Love Machine. Gray Walter and the Politics of Electroencephalography. Hayward, Rodri. Science in Context 14.4, pp. 615-42. The Curve of the Snowflake. Norton, 1956. Also published in the UK as Further Outlook, London. Duckworth, 1956. Science fiction novel concerning paradoxes and the Koch snowflake. Chapel of Extreme Experience. A Short History of Stroboscopic Light and the Dream Machine, New York. Soft Skull Press.